Hi, I'm Gautam Kurmela. We have Amritanshu Jain, co-founder and CEO of Simplismart.
What we are is the fastest delivering inference engine. Right now you were serving like a request a minute, right? Now it'll be like you are serving 100 requests a second.
Welcome to Seed to Scale, AWS, inside the engine room. We have Amritanshu Jain, co-founder and CEO of Simplismart. Welcome, Amritanshu. Simplismart claims to have built the world's fastest AI model inference engine. What are the core innovations in your engine's architecture and that enable this kind of model performance?
Fair. So I think like there's a lot of stuff. I'll probably try to cover each one of them briefly. But before as we say that we have built the fastest inference engine, but I still believe that comes through modularity. And our idea is not just like building the fastest inference engine, obviously like you market it like that, but the idea is that you have that kind of flexibility when an enterprise, a user, they want to go for a use case, right? So let's say if I'm a company and I'm building like a voice agent, right? So what I need is like real-time responses. That is where you need the fastest inference engine. But when you're doing these batch use cases, let's say like a use case like document processing, that is where you need kind of like the cheapest inference engine because latency doesn't matter that much and you would want to be cost efficient. So like our idea actually came through where we wanted to kind of navigate through these trade-offs, which is like cost, latency, throughput, and accuracy, right? How do you navigate through these? And what we did was we reimagined the inference stack in a very modular way. So imagine when you are building an inference engine or you're using an API, it's generally like a glued down inference engine that like people use. So that means if you're running a Llama 3.18 billion, the throughput that you get is 150 tokens per second. You can't get 450, you can't get 50. So that's like the kind of rigidity that we don't want for a user when they're using this inference stack. So we basically kind of broke it down into granular parts saying that, okay, this is the serving layer of the inference engine, right? This is the compilation layer of inference engine. This is the infrastructure management layer of inference engine. So there are a ton of things that kind of combine this. And what we did was we broke it down and we made it into a modular structure. Now, what you can do is, let's say there are a ton of frameworks out there, right? Sometimes VLLM is the fastest, sometimes SGLang is, sometimes TRT-LLM is, and this is just a race as we are like playing it, right? But the idea is every day there is a new research coming in, a new inference technique comes in. So the idea is how fast can you actually integrate that into your inference engine? And again, coming to the whole point of fastest inference engine, I think the benchmarks are finally going to converge at some point of time, right? They're probably going to converge. But what we are is the fastest delivering inference engine, if that makes sense, which means that if it takes someone 6 months to kind of incorporate a particular inference technique in their inference engine, it takes us a day. And that's because of the modular architecture. So we are always ahead in the race, like 6 months or so, but it's basically because of our modular architecture. So we do a ton of things. We have written our own kernels. We reimagined the serving layer that we built for inference engine. Can you do like dynamic in-flight batching, things like that? But yeah, I think like in the end, it comes down to how good engineering systems are, how like good can you stitch those engineering systems together like Lego blocks and stack it like that.
That's right. And especially when you go and talk to enterprise customers, you know, beyond all of this stuff, what you talked about from a performance standpoint, they look at security and controls as well, right? So what is your mental model around, you know, building those modular blocks and how those things got prioritized from your development cycle standpoint?
Yeah, I think like that's why like we have like a much easier time kind of trying to convince enterprises to buy our products rather than like the smaller ones, because like when you're starting out, I think pay as you go, like shared endpoints, these kind of things, they really attract the customers, right? Because no one wants to manage the GPUs, no one wants to kind of take a one-time cost, like because right now hosting like a model becomes like a one-time asset cost, one-time capital investment, right? and this just becomes cheaper, this just like becomes easier to manage. So they would definitely use shared endpoint, but as you rightly said, with enterprises, they would want data privacy, they would want the control of their infrastructure, because they cannot rely on like a third party engine for their uptime, for their SLAs, because a lot of times the uptimes are not that great, even with us, maybe like on shared endpoints, because the load is like really dynamic, right? So again, as I said, like because we have like reimagined the inference stack in a very modular way, we have built it in a cloud agnostic way, in a chip agnostic way. So it would of course work amazingly on AWS, but almost as amazingly on other clouds as well, even on on-premises systems, right? When like, so one of our recent customers where we deployed our model on around 60 H100s, and they kind of took these GPUs from a data center. So we also do on-prem deployments, things like that. Especially like I think with industries like BFSI and healthcare, they're really, really picky about like compliance, data privacy, where the data resides. And yeah, I think like again, working it in a cloud agnostic and chip agnostic way, which also means that it does not just work on NVIDIA chip, it also works on AMD. It also works on Inferentia, right? So Inferentia, I think like that's great for vision models. That's what we have tried with a couple of customers. So yeah.
And how are you actually solving some of the gaps in the MLOps, especially from an enterprise lens standpoint? What challenges that you saw, and how are you solving those things today?
Okay, so maybe like this might be a little longer story, but I'll try to lead with the story, right? So I'm an ML engineer in an organization. You are my VP of engineering, and you basically get this requirement from product and business that hey, let's try to build one use case. Let's take a voice agent, right? So what you will do, this sounds great, we have to automate customer support, and you'll come to me and you'll be like, Amritanshu, you have to build a voice agent. And I'll be like, yeah, that seems pretty easy, right? So I'll go to Google, what is the voice agent framework? I'll take a voice agent framework, I'll take my shared endpoints of speech to text APIs, LLM APIs, text to speech APIs, build that into my framework, do like interruption handling, things like that, and I'll have like a good POC in front of you in a week or so, I think. And like that's I think the easier part. Now you say that this MVP looks great, right? Let me like take it to business, let me take it to product, if this makes sense. And it actually did make sense to them. So now they'll come back to you and they'll be like, so when do we go live? And then as a VP of engineering, you are like, this will even take time to imagine how much time it will take me for this to develop, right? Now, because you are, let's say, a healthcare company, can't use shared endpoints. That was just a POC, right? We'll have to build this infrastructure control in-house. Whenever you are deploying a model, as people say, right? It comes off as really easy because you see a blog and you are like, this seems fine, this seems easy. But again, when you scale it, I think there are a plethora of problems that you haven't even imagined, right? Right now, it's just like an MVP, a POC going on. Maybe it crashes, maybe it does not. But this is something that you can't afford. And these seems like just small plumbing problems. But when you try to scale this, you realize that it's not like a plumbing problem within the pipeline that you have built. We'll have to lay out the pipes again because the scale is massive. Right now, you were serving like a request a minute, right? Now it'll be like you are serving 100 requests a second. You have to reimagine that pipeline. So I think there are, again, like a ton of problems when you are doing MLOps. The MLOps as like an umbrella term, it's like really, really large. I think we're solving like a part of it because MLOps will cover that, okay, I have my data, how do I clean it, how do I prep it, then how do I train the model, how do I fine tune the model, how do I version them, how do I version the data, then basically take them and like then deploy the model. Do I scale it? Do I get my DevOps engineering teams involved? Because I do not know what Kubernetes is, right? I do not want to deal with that. I'm a machine learning researcher. And then you have to build observability. And we all know engineers hate to do that, and that's why CloudWatch is taking off, right?
Yeah.
So yeah, I think there are a ton of pieces that people do not realize when they're building this MVP. Even so, like I'll tell you, just this might seem like a very small problem, nothing to do with our inference engine, just a part of our stack observability, right? And we had to collect logs. That's all. Like you take it in Kibana or something like that, you collect these logs, and like our one of our customers like scaled like crazy, and this is just like I think 2 weeks ago, and they scaled like 30x. So they were like running around 4 GPUs, and this suddenly scaled to 120 GPUs. The thing is, surprisingly, nothing failed on the inference side. We were able to get the GPUs within that time. We were able to scale to that within the same SLAs. But it did fault at some point. And the point at which it faulted was the disk ran out of memory when they were trying to collect logs. So I think like it's just like it's very ironic when like the biggest problem is just like inference and performance and optimization. But around that, there are so many things that you don't think about developing from a standpoint of productionizing it when we say productionizing a service. But again, I think in MLOps, the exact problem that we are trying to solve is to optimize for performance. Of course, you get like adjacent feature ecosystem to kind of go through and like go with productionizing the service. But the problem that we try to solve is the grid search hell problem, as I like to put it, right? Because again, I think like we started the conversation from there, again, coming back to that, where when I am an ML engineer, what we didn't talk about is I took these shared endpoints, but when I'm going to deploy the model, right, what I will do is I'll take a Llama 3.18 billion, I'll download VLLM on a server, I'll try to run that Llama 3.18 billion with that VLLM, right? Now I will try out the 100 configurations of VLLM, all the PNCs, right? This takes me 1 week. Why does it take me 1 week? Because I have to benchmark every time I do that configuration. And VLLM, TRT-LLM, SGLang, as great as open source frameworks they are, they're not stable, right? So you have to like do a lot of plumbing by taking in your repository. Then you did it with VLLM, but you are not sure if this performance is optimal for your particular use case, right? Maybe then you try out SGLang, then you try out like TRT-LLM. You try out all these frameworks and you just didn't realize that 3 months has gone and the service didn't go live, right? Because you were just trying to kind of find that sweet spot between the cost and latency. That I just want my SLA within 800 milliseconds. And it'll be so great if I get the cost at 7 cents per million tokens, right?
And we completely miss the time to market.
Yeah, exactly, right? So I think that's again like a great thing. Obviously, like you help in going like live really, really fast. Sorry. Where you are saying that it'll take me 3 months to even realize that, okay, this is the exact configuration of this is the exact deployment strategy that I should go about by deploying this model. Problem is the market is so fast moving. In 3 months, that model is irrelevant. And the framework that you decided on is again irrelevant because another framework came in and it just took it by the storm. And now you have to do the whole exercise again. So you just get stuck in this loop. Like this is what we talk to customers. You just get stuck in this loop. You're never able to get out of it.
How are you solving that internally?
So we say that you tell us, I want 7 cents per million tokens and 800 milliseconds of SLA in my response time. And we'll give you that model deployed within those SLAs with that cost next day.
Yes.
That's what we solve for.
Oops. Can you just share 1 or 2 examples of customers who have actually realized the value of using Simplismart today?
100%. So I might not be able to name all of them, but so I think like this is again volumetric like wise, even in terms of revenue or like the usage, one of our biggest customers. And I think for them, we solved the cost, and we solved the cost greatly for them because just briefly, they were spending about $22,000 a day on GPUs. They use Simplismart, not tell what we kind of take from them, but their GPU cost went down to $3,000 a day. And that's just because the optimization part of it, the thing where we say fastest inference engine, that part actually contributed, let's say, getting it from like $20,000 to $25,000 to $15,000. But the other things, again, I think it's great that I'm having this conversation for you. No better person to tell you about this. But this is what you do with your customers as well, right? Can you stop those leakages? Can you just do better monitoring, right? Can you scale better? Can you rapidly scale that? Can you try to not over provision, right? There are these things seem so small, but they have such a larger impact. So again, on that point, I think just scaling. Let's take out the whole performance point of view, the whole compilation, kernel writing, this and that. Let's say it's just not there, right? And there's this good SaaS company. It's a really good SaaS company, and they're into sales enablement. And we solved like speech to text for them. We like brought down their cost. We brought down their, like with Whisper model, we are doing like 1300 RTF, which basically means for a 1300 second audio, it'll take 1 second for you to transcribe it. So cost obviously goes down, but the speed is like crazy, so with Whisper, you were not able to stream it because there was like an overhead, but with this, you can do that. So this company, we solved obviously that part for them. But the second thing that we tried to do was just rapid scaling, right? This is like one of the biggest challenges that enterprises face. Again, not like a better person I can talk to this about. But the idea is because these generative AI workloads become really, really spiky in nature, right? One moment you are doing like 10 RPS, the another moment you are doing like 50 RPS. And this movement basically is 30 seconds. So how do you like rapidly scale up from like 1 node to 10 nodes? And if you're not able to do that, you breach the SLAs, your fault, you like fault your request, things like that. And the worst thing that happens with you is you try to over provision and like a lot of cost leak, right? So we just introduced rapid auto scaling, where like a model was taking like 6 minutes to auto scale, and we brought it down to like 20 seconds. And just through this rapid auto scaling technique, we were able to save them 25% of the cost. So let's say they were paying like $100, we brought it down to $50, and then we again brought it down to around $38.
Amazing. That's a fantastic innovation.
But yeah, I think like it's like obviously one core thing is basically how do you make that inference engine modular? How do you make it more performant, optimize, and things like that? But the surrounding things, that is something that people generally don't think about. And like this, it's our job kind of to educate the customers on it and like help them in that way.
Right. Slightly switching gears again, let's shift our focus towards hiring. As co-founder and CEO, how did you went about building your initial team, and how it evolved over a period of time?
I think like initially, so we still are kids, I think, but like we were like 3 years back when we started the company, we really didn't know anything. Like we came from an engineering background. We just got like our paychecks. We wrote good code. We knew that, but like it was like maybe hiring might not be that difficult. And like everyone told me that like maybe fundraising is the most difficult thing, and second close is hiring. I think hiring is the most difficult thing. Fundraising might come a close second or third, but identifying good, like what I have generally done, what I have realized is, and again, we have made a ton of mistakes, and like it's not about like particularly about a person. It's sometimes just about the fit, right? Can you communicate properly? Like the person in front of you can be like an amazing coder, an amazing salesperson, anything like. But I think at least when you're building your core team, one thing you should definitely think about is, can I work with this person, and outside of office, can I have a beer with this person? Because sometimes the second one is not very true. Like this is something I realized, and I think like one thing that, so initially what we did was we hired like 4 interns. That was our team. That was Simplismart. Me, my co-founder and CTO Devansh, and 4 interns, and we built out the whole platform in 6 months with the help of interns, and we burnt nothing. Like this didn't take any money. We didn't like take an office or anything like that. Slowly I started realizing interns are great if you want to get like cheap work done easily, very bluntly, but they might not be the most reliable people. They like some of the best engineers that we have full time right now, who have been with us since the last 3 years, joined us as interns, and we got to pay them like really low when they were interns, but no. But look, they turned out to be great engineers. But I think like I had this ideology that I'll just take interns. I am like a good enough coder. Devansh is a good enough coder. We can like kind of just guide them and make them learn.
There's a constant mentoring and coaching effort that
Yeah, but you
put in.
can't do that. Like you can't do that. You just become a manager in your own company, and that's a full-time job, like being a manager. And I don't like being a manager that much. Like I'm more of an IC person. I am not like so yeah, I think like that's one of the other things that I generally like to do and optimize for myself. Let's hire people who don't need management. Like,
Awesome.
Yeah, I think like that's one thing. And the other thing that I generally see is something that also is called as keeper's test, which I think like was worked out really great for me. I'm not sure if it is called keeper's test or something, but I heard it in a podcast that it's very difficult to judge people in like an hour of conversation and like just list down pros and cons. That this thing looks great, this might not be the best thing, this. But how do you kind of quantify it? How do you objectively think about hiring a person or not? So you just think about, in a parallel universe, if they would have their own company, would I work for them?
Yeah.
So I think that has definitely worked wonders for me. But yeah, I think like from there on, generally I have just focused more on, I think, so like in our kind of business, it's not that you have to be the best engineer, which might sound very counterintuitive, but it's just the drive in the people. Like I have seen that whenever like a competitor even surpasses our benchmarks by 10%, AWS did that like just a week ago, I think. And then the whole team is like so driven that they can't be the best. Like they can't be better than us. We have to get there. And maybe they didn't find a solution just a week ago. And now they're like, we have to find it. We have to be the best in the world. And no one can surpass this. So I think that's might not be like the best now. I'm not sure. I'm not able to find that word, but there's like
It's more driven. Yeah.
right? So we need like those kind of people who have this chul of being the best at what they do. And if they're hardworking enough, I think skill is something that's like really comes like as a low priority for me. That even if you don't know coding, if you don't know sales, and you work hard enough, you actually want to do this excites you, I think I'm willing to spend like 3 months with you and like totally just like be with you and give you the context. Maybe if I know that skill, train you, or like get someone to train you. But I just working with those kind of people who emit that kind of energy kind of just extrapolates the energy of the team as well exponentially.
Right. Again, looking ahead, what excites you? What kind of technologies? What kind of research that you are focused on? And, how are you building the roadmap for your...
I think right now it's about how do you expand it from here. So you got like one core product working great, amazing, you got some traction. But what people would want, again, going back to that point where like MLOps is a big umbrella, right? Everyone is an MLOps platform. Weights and Biases is an MLOps platform. We are an MLOps platform. Predibase and Sloth will be an MLOps platform. Everything is like an MLOps platform right now, right? SageMaker is an MLOps platform, right?
Been there for a long time.
Exactly. Like the OGs of the MLOps platform. So I think it's more about how do you now develop the application tooling layer. So I like, at least in my thought process, what I have seen is 2 years ago, everyone was like, okay, there's something called an LLM and it's like going viral. What is this, right? A year ago, people were like, maybe this makes sense. Let's try this out. Maybe this can solve something for us. And I think right now the sentiment is, okay, I found this use case. This works for me, right? Every enterprise, every company is like, they found one use case, at least one use case. This works for me, right? And now they are trying to productionize it. at like before this, I don't think right now the customers are like kid in a candy store, right? They want everything, anything, right? They just don't know what they want right now. And I think, I'll think on their behalf. I think right now what they wanted was just, can I basically test out this LLM, right? Can I get a deployed model? Can I get an API? Can I interact with this model? Can I experiment with it? Can I test it out, right? And I don't have to go again through this VLLM deployment and this and that. I just take an API and start inferencing, right? Now no one needs like, I don't want like a Llama 3.18 billion API. Everyone is giving that out, like everyone, literally everyone in the world. What I want is, I am going to basically take a ton of unstructured data and going to convert into JSONs and then trigger actions, right? So can you give me the basic functionalities of function calling, right? Again, just a basic thing. And this is where you start basically building the application tooling layer. Can I come in and connect a vector database with the API that you have given to me within your platform, right? Can I, I think Whisper would be a good example, because speech to text is already a mature industry. It also started it with like ASR models. It was like, I think 2016, 17, Kaldi and all came out. And everyone was struggling with, can I just get a good transcription, right? I'm not even able to get a good transcription in English language. When people started getting that, they were like, okay, this is something that everyone can give me, right? Can I get like a voice activity detection system? Can I get diarization? Can I get summarization? Can I get this and that and this? So I think now is the time when you start building an application tooling layer on top of it, which not only enables them from like an inference point of view, but actually works for them from a solutioning point of view. Solution cells, again, not a better person to answer that. You have been doing that for a while now. But I think, yeah, so we have to move our platform towards like a solutioning nature, where maybe right now they don't have to come to us or go to an implementation partner, or actually spend a bandwidth, take an ML engineer and tell them that, okay, build this rack system for me, or like maybe build these chainlets for me, or build this function calling, build this agent for me. So can we get that kind of application tooling layer on top of our like inference engine, and not just give an API out to that person, right? Then can I help them prepare the data? That's like, I think if you do that, I think that's a great startup idea. I have been wondering about it, but I think if someone builds data prep agents, this is going to be like, this is going to be like very big. Because right now, everyone, when they start using these LLMs, they're now like, can I fine tune this? And when you want to fine tune it, every big enterprise is like, hey, I have a lot of data. And I think that's the problem, because who will prep that data, right? And with with good agents coming now who can actually automate these kind of things, I think this would be a really great thing to like basically go in. Then evals, again, I think is another thing. But I'm not saying that we have to build all of these things. We also have to focus on partnering with our adjacent companies, right? Can I partner with a company who is like doing LLM evals really great, right? Can someone build a data prep company, please, right? And I can use them in our workflow. So I think it's now more about completing the loop for a customer, that can they start their journey from here and end their journey from there, and basically just run that loop through Simplismart.
Yeah, exciting days ahead. Thanks for joining us today, and thanks for sharing your learnings.
Thank you.
I really appreciate your time, and always great to chat with you.
Likewise. Thank you.
Thank you.